This is the section 10.1 presentation where we start to discover and study circles. And the first thing we're going to learn are the different parts and pieces that can be attached or associated with circles. And I'm not going to really go in depth into this story, but this was shared with me with Tom Sherritt that one of the most efficient methods or modes of transportation are trains. And when gas prices are really high, and they're not right now, but when gas prices are really high, trains are a really attractive option for shipping things across the country. And one of the reasons why is because they're unbelievably efficient. If you notice, I've got the dime here and I've got the train pictured. And the reason why these two are related to each other is that at any one time, any of the wheels that are on like the train cars or the train engine, the amount of that's touching the actual track, the amount of the wheel that's actually touching the track is only about the amount of what's in a dime. So there's very, very little friction on trains when they are traveling down tracks. And you've probably heard the expression like it's hard to stop a train. I think that's even the slogan of the train company, and they use that to indicate how I guess robust their heating and air conditioning units are. But if you've seen a movie and the train's trying to stop and there's somebody on the tracks, like they can't stop and they lock up the wheels and the train keeps on moving because there's such little friction. It's really, really difficult to get a train to slow down because the only part of the wheel that's locked up is the part of the dime. The reason why this relates to circles and parts of circles is that when I think of tangents, and tangents are segments that touch a circle um, in one spot, the closest thing I can think of in real life or a real life application is a train circle wheel and the straight train track. And that's the closest, I guess, real life application I can get of a tangent in real life. So we're going to talk about circles and all the bits and parts and pieces of circles and what is a circle. So a circle is defined mathematically as a set of all points equally distant from another point. So what would happen, I guess, in the olden days of studying geometry is a person might take a string and a stick and actually probably two sticks, put one stick in the middle, and then with the string take the stick and then draw it all the way around that point. And this is a circle right here. These are all the things that are equally distant from point C. And then when we name a circle, we name it by its center. And symbolically, we have a little circle with a little point inside of it. And then we use the letter to represent a point and the center of a circle. So in this case, this is circle C right here. This is circle C. That's how we name it. What's a chord? Well, if you've been in the music program and you've taken either band or choir, chord means something different to you. But in a chord, in a circle, it's just a segment inside a circle whose endpoints are on the circle. So in this case here, I have circle C. This is the center point of the circle, and I've got this chord AB. Now, sometimes students will get confused between other types of parts. So just so example, if I did something like this and then turned this into a ray. So this is ray BA here, but I do want to point out I still have chord BA or chord AB inside of the circle. So if I say chord AB, I wouldn't be representing everything here. It would just be the part whose endpoints are on the circle. So chord AB is just the part that's inside the circle. So that's what a chord is. A radius is a segment that goes between the center and any point on the circle. And that's going to be really important as you move later on into mathematics because the radius of a circle is like super wickedly important. So that's something you want to really get down. So again, a circle can have many radii, that's plural for radius, as long as I am connecting the center of the circle to somewhere on the circle. So if I go this here, then I have radius DC, or I can call it radius CD. I don't have to name the center point first when I name a radius, because when you name a chord, you can name it by either endpoints. So segment AC is a radius. Also here, segment CD is a radius. All right, a diameter is a chord that contains the center of a circle. So that's just the way that we define a diameter. It's the distance across a circle. Now, when we're saying across a circle, it's got to include the center of a circle. So if I do a segment like this here is not a chord because it doesn't contain this center point that's right here. It's kind of small to see, but you can see the center point there. So as long as I've got a chord and at some point it's touching the center of a circle, then it is going to be a diameter. All right, secant. A secant is a line, and it could be a ray, that intersects a circle in 2 points and it keeps going. And a few slides ago, I defined chord AB as a segment whose endpoints are on a circle. When I keep going outside the circle in both directions, that becomes a secant, okay? So line AB is a secant, segment AB is a chord. So if it touches a circle in 2 spots and keeps going outside in both directions, it is called a secant. That one might be a bit new for you. Tangent. Tangent can be anything that touches a circle in 1 spot. So it could be it could be a wall, so it could be a plane, but it could be a line, it could be a ray, it could be a segment, it could be another circle. As long as it touches a circle in just 1 spot, it's going to be called a tangent. So this was like my railroad engine in car example where the wheels of the railroad car are touching the lines of the track in just 1 spot. And that spot that's happening here is point A. So this point A is important. It's called the point of tangency. So when you've got a item touching a circle in 1 spot, that 1 spot where it's touching is called the point of tangency. All right, so here we got a drawing with, holy cow, a lot of stuff here. So let's name the following, and some of these can have different names, and some of these are locked and they can't have different names. So I'm going to kind of cover that a little bit so that we get everything down here. So the circle, there's only 1 point inside the circle that's identifying the center, which is point G. So this is circle G. Radius, we have 2 of them. We have a segment going from F to G, and we have a segment going from G to C. And there's 2 different ways that we can name these segments. So you could actually have potentially here 4 different answers, although I'm pretty sure I just have 2. So first one is segment GC here, and that's going from this point here to the circle. And then I have segment GF, and that's going from this point here to the edge. And again, I don't have to name it by the center point first. Might be a good idea to do that, but as long as you've got the 2 endpoints of the radius named, then you're in good shape. Diameter, that's just going to be a chord that contains the center. So segment FC or CF, depending on how you'd want to name it, is going to be a chord that contains the center of the circle. Secant, it's got to be something that's touching the circle in 2 spots and exiting the circle in both directions. So in this case, I have E and K here. I have chord EK, but I have things leaving the circle in this direction, and I have things leaving the circle in this direction. So my secant here is going to be secant EK, or line EK. Tangent, I've got a couple of options here. I've got 1 point of tangency here at M. This is what's touching the circle in 1 spot. I could call this line MZ, segment MZ, ray MZ. I've got a lot of options there. In this case, I just went with the biggest option, which is line MZ. And then chord. There's actually several chords here. Segment FC is a chord. It's a diameter, but it's a chord. I've got segment EK, not line EK, but segment EK is a chord here. But something that's just all by itself as a chord and not being or doing anything else would be this one right here, which would be segment JD or chord JD. So there are actually other ones here, but in this case, the one that's only serving the purpose of a chord is segment JD. All right, so let's use the picture to find the given lengths. So you'll notice here I've got circle G, I'm noting the radius length between G and C at 6.5 centimeters, so there's not really any work to do there. Segment F and G, this is also a radius here. So I've got a radius from G to C. I've got a radius from G to F. So if this is 6.5 centimeters here, this has to be 6.5 centimeters here as well. And then the length of the chord is just going to be adding up the two 6.5 centimeters, which is going to be 13 centimeters. All right, coplanar circles are circles that are just together in the same plane. So as long as you have circles in the same plane, you're going to have coplanar circles. And then they can be special circles in addition to being just coplanar. If they are circles in the same plane and touch each other in one spot, we call them tangent circles. So this kind of looks like a snowman, sort of-ish. I guess it's sideways. So if I have two circles touching each other in one spot in the same plane, they're called tangent circles. If I have circles that share the same center but different radii or different diameters, they're called concentric circles. So this kind of looks like concentric circles. So all these circles share the same center and they're in the same plane, but they're not touching each other and they don't have the same radius. So those are called concentric circles. Circles can share tangents. If I have circles that interlock, kind of like the Olympic circles, they'll have two tangents here. So one at the top and one at the bottom. If I have two circles that are not touching each other at all, they're going to have four tangents. So here's a tangent line here, one here, one here, and then one here. And you'll notice I either have them interlocked or not touching. What happens if they're tangent circles? Oh my gosh, what happens if I have two circles that are tangent to each other? How many tangents would they have? Are you ready for it? Wait, wait, wait. Not yet. Now? No, not now. Now? Okay, now. It'd be three tangents. So you'd have a tangent at the top, you'd have a tangent at the bottom, and then you'd have a tangent in between them. All right. So that's your basic introduction to circles and circle parts. We'll get more involved with them in the next presentation, but at this point, I need you familiar with the parts and how to do the parts and what the parts are. So for Tuesday, I want you to do questions 1 through 10. Hang on to them on page 645. Don't send it to me. Then on Wednesday, I want you to do problems 11 through 17. And then when you have both of those done, send me in an email problems 1 through 17 from page 645. Thanks for listening and watching.